Welcome back. In this video we're going to continue our journey in learning about the development of modern atomic theory. In this video is a little different. We're getting kind of off the chemistry timeline, if you will, or the atomic timeline, and we have to talk about some important work that was going on before we started actually discovering what's inside the atom. In the 19th century, physicists were studying electricity and electrical phenomenon in great detail, trying to figure out, what it was, what created these sparks of energy or light or whatever they didn't know what it was. So there was an important discovery made in I forget, mid to late 19th century, and it was called a Crooks Tube. I think it had some precursors, but when a man named William Crookes made his, that really became like a laboratory standard. And what a Crooks Tube is, let me just kind of fast forward. We'll come back here on to where we need to be, but for right now let's look at this Crooks Tube. So the important thing about it is that this is just a glass tube, and there are electrical plates on each end, and inside this tube they hook up there's a vacuum, because they hook up a vacuum pump to this tube and pump out all the air. Okay, so then what they do is they hook an electrical source up to it, like jumper cables or something like that, or a battery with the wires. You can see the wires in the video here hooked up to different parts of the tube. Now, what the phenomenon that occurs here is that you get an electrical discharge, and the electrical discharge shows light, like a glowing fluorescent light, and sometimes it even sparks if you put enough voltage through it. So the bottom picture there shows you kind of what was seen. So now let's go back and let's talk about the next three people who either made a serendipitous discovery or really worked very hard to make sense out of this new information. So this is going to be Röntgen, Becquerel, and then the Curies. So the first person made an accidental discovery of the X-rays in 1895. Now, he wasn't a bumbling idiot and didn't just trip over it as he was coming in the front door. He was doing experiments. He was working with these Crooks tubes, trying to figure out what was going on, what was creating this glowing phosphorescent light from these Crooks tubes. So what he did was he covered the Crooks tube up with like a dark curtain or a piece of fabric. Anyway, he wanted to black it out. And then while he was doing that, he did his experiments. It turns out that he had a phosphorescent screen in his lab about 9 feet away or so. And after his experiment, he observed that screen across the room had been like exposed. It was glowing and stuff. So he knew at that point that whatever was being produced, at least some of what was being produced in that Crooks tube, were unknown rays that were able to penetrate black cloth that you couldn't see through and go hit that screen. So he didn't know what they were called. He called them eventually X-rays, where the X is kind of like for unknown. From that point, he started running around experimenting with things. He started putting other objects between the screen and the Crooks tube, and eventually he recognized that when he put his body parts there, that he saw a kind of a ghostly image form on the screen, what we typically know today as an X-ray. In fact, he had his wife famously put her hand in between there and exposed her bones and had the big ring showing there. And she said famously, "I have seen my death." But anyway, it was a very important discovery that these X-rays indeed exist. And he won the Nobel Prize in 1901. So this set other physicists on a new pathway for greater discovery, one of whom was Henri Becquerel. He was a Frenchman, and he had been studying minerals, and he was very, very well versed in this area of science. And he came across Röntgen's discovery, and so he thought maybe he could relate these X-rays to some of the some of what he knew and could had experienced with uraniums and uranium salts. So anyway, he sets out to do so. And actually, what he was working on more was like phosphorescence. Phosphorescent minerals are those that you put them out in the sun, they absorb all the sun's energy, and then when you turn the lights out, they're still kind of glowing. So he knew uranium salts could do that. So that's kind of what he was looking at, phosphorescence. But anyway, so he ran some experiments. He had some photographic plates, and he wrapped them up in material so that the sun wouldn't hit the plates. And then he would set some uranium salts on top of the plates, set them out in the sun so that the uranium salt would absorb the sun, and then lo and behold, there was exposure of the plates even through the blackout material. And so he was like, okay, so these X-rays are what's causing it. This is what's going on. But it turns out he was wrong, because he also had a serendipitous discovery. After he had presented his wrong information, he went back to his lab, maybe, we don't really know why, but maybe just to do it again, just to prove himself. And he got his experiment set up. He had his photographic plates, he wrapped them up in the dark material, and he had his uranium salts, and then suddenly the weather changed. And it was very dark outside in Paris. This was during the winter, I believe. I think it was in February. And it was too dark, and it stayed dark for 2 or 3 days. So he, I guess, kind of knew from the state of the weather that he was going to be a few days. So he took his stuff and put it in a drawer, closed it. And then Becquerel came back a few days later, for some mysterious reason, decided to take out that experiment with the photographic plate, and he decided to go ahead and expose that plate. There shouldn't have been anything on it, according to his work, because there had been no sunshine. But he decided to expose it anyway, and lo and behold, there were images. At that point, he knew that the rays, as he called them, coming out of his uranium salts did not require sunlight to be activated. They spontaneously arose from these uranium minerals. That was a huge discovery. Now, at that point, some other people picked up Becquerel's work and said, is it light? Are these spontaneous rays light or energy? And so they did some experimenting on it, and they discovered that these rays coming out of the uranium salts could actually be deflected in a magnetic field. So that proved they were not energy. Instead, they were matter. So here we have this for the first time. Matter is coming from other matter. It's being emitted from supposedly atoms. Maybe a clue that Dalton was incorrect about the indivisibility of the atoms. So the next group working became the Curies. Becquerel thought this was just a phenomenon of uranium. But what Pierre and Marie Curie did was set out to kind of isolate the sources of these radiations, we'll call them, just for lack of a better term for now. And they did just tedious and amazing lab work for years and years and years. I think I read somewhere that at one point they took 10 tons of rock and dirt material and boiled it down, crushed it, separated it until they got 0.1 gram. So 10 tons became 0.1 gram of a new radioactive material that gave off these rays, and they called that radium. At the end of the day, they were credited with discovering 2 elements, radium and polonium. And now this is important because it opened up the idea that these rays, these particles, really more correctly now, were coming from many minerals, many what will become elements. And so now that we've sort of established this phenomenon that Becquerel stumbled across and the Curies far and away proved existed, we run into some work now in England. The University of Cambridge was sort of the center of learning at the turn of the century. And one of the men we're going to read about here again in a few minutes was Ernest Rutherford. He was a student of J.J. Thomson. We'll get to him as well. But in the meantime, Rutherford did a lot of work with these radioactive particles. I think he was in Montreal at McGill University during this time, and he and his students set up many experiments to kind of figure out what the heck these particles coming out of uranium and polonium and radium, what were they? So he designed a pretty ingenious little apparatus. It was similar to a Crooks tube, the little glass tube, except that he made it annular, which means there was a tube inside of a tube with a very narrow space between them. He lined the interior tube on the inside with radioactive, like dust, like some uranium, very, very thin uranium, like almost like paint. And so he knew these particles were pretty weak. They could be stopped by something not that thick. And so after running this experiment and measuring, what was going on with these particles being trapped in that little annular space where there was nothing, turns out he found high levels of helium. Well, to make a long story short, the result of that experiment by Rutherford showed that these particles coming out were basically the nuclei of helium. They were +2 charged, and then when they would hit the glass walls and interact with it, they were stealing electrons from the glass, and that was why they became helium atoms with 2 protons and 2 electrons. So he, Rutherford, and his team, his students deserve credit as well, they did a lot of independent work, are really the people who discovered and named alpha radiation, beta radiation, and so forth. And we will follow up at the end of this unit on that. But for now, that is sort of what was happening in the world of physics that led up to some discoveries coming up for what's inside the atom.